Now I'm going to discuss some problems on Unit 5 EC3251 Circuit Analysis. Okay, now the question is find V0 in the circuit shown in the figure. Okay, find V0. They ask us to find the voltage V0 which is across the 0.5 farad. If you look at the circuit is in time domain. Circuit is in time domain. Okay, the time domain circuits need to be converted into phasor domain or frequency domain equivalent circuit. Okay, so for that you have to look at my previous video for conversion. Anyway, I'll be discussing in brief how do we perform the conversion. If you want in-depth explanation, you need to go through the video which I've shared in the description, as well as you can simply browse for the previous video. Okay, so here the question is in time domain. You can see the voltage source is 24 cos 2t volt, and the inductor value 2H, and the capacitor value is 0.5 farad, and the mutual inductance is 0.5 Henry. Okay, this is mutual inductance, M, we call it as M. So this I can call say L1, this might be L2. Okay, this is my C. Okay, these are all the values given in the circuit and all are in time domain. Now first thing is we need to convert that into the frequency domain. Okay, we need to convert that into the frequency domain. Okay, see, we need to know this particular table. Okay, if you don't know this, kindly write it down. You need to know any two of this so that we can write for all the possible values. Okay, Vm cos omega t plus phi, it is a general form. So we have Vm cos omega t plus phi, this is the general form. Here it is written as 24 cos 2t, but we don't have phi, so I can write 0. So I can consider phi is equal to 0. So in the place of omega we have 2. So omega can be 2 radian per seconds. The unit of angular frequency is radian per seconds. It is important to write down the unit for each and every cases. Okay. Now the general form is Vm cos omega t plus phi. In the phasor domain, that will be represented as Vm angle phi. It is represented as Vm angle phi. Okay. So here phi value is 0. What is Vm? Vm is equal to 24. In the place of Vm we have 24. So we can write 24 cos 2t can be written as 24 angle 0. Okay, so it can be written as what? Okay, give me a minute. So this can be written as Vm angle phi. So in the place of Vm we have 24. So 24 angle phi is 0. So this is the value we got in the place of voltage. So I know what is omega. Omega is 2 radian per second, and I know what is the voltage available. Okay, so next thing is I need to convert all the inductor value, mutual inductance and capacitor value into frequency domain equivalent value. So for inductance, L will be represented as J omega L. Okay, L can be converted into frequency domain using this J omega L. Okay, let us take 2 Henry. So we have 2 Henry here. 2 Henry can be written as J times, what is omega value here? 2 radian per second. Okay, multiplied by the L value is 2. So we got 4J, and the unit is ohm. Okay, so in the frequency domain the unit of impedance will be considered as ohm. But in the time domain, for inductance we have Henry, for capacitance we have farad. But if I am converting into the frequency domain or phasor domain, you will be representing all the impedances in ohms. Okay, so here this can be represented as 24 angle 0 volt, and this can be represented as 4J ohms, and this 2 Henry, again this L also 2 Henry. So this will be applicable, for the same formula can be applicable. So this also can be written as 4J ohm. What about 0.5 Henry? M will be written as J omega M. Okay, J times omega is 2 and M is 0.5. So 0.5 is 1 by 2, so we got J. Okay, we got J. So instead of this I can write J ohm. Okay, the coefficient of J is 1. Okay, so next case is we need to write for 0.5 farad. For capacitance the formula is different. C can be written as 1 by J omega C. So it is 1 by J times 2 times 0.5. Okay, we will be getting 1 by J. Okay, we will be getting 1 by J. So this 1 by J can be written as minus J. Okay, minus J ohm. Okay, in the complex number 1 by I will be written as minus I. Similarly, instead of I we are using J here. Okay, so 1 by J can be written as minus J. Okay, 1 by J is equal to minus J, and the unit is, okay, so here the unit is written for capacitance is ohm. So all the values are written. Okay, so instead of the 0.5 I will be writing minus J ohm. This is the value we got. Okay, now we will just refer to the next slide. So 24 angle 0 volts, J4 ohm, J4 ohm, this J ohm, this is minus J ohm. Okay, minus J ohm. Okay, now we need to apply KVL for both the loops, and we'll be getting two different equations. We need to solve the equation and find out what is V0. Okay, we need to find out what is V0. So first of all, we'll apply KVL at coil 1. This is magnetically coupled circuit, so you have to remember it. It is different from solving the problem in AC analysis. Okay, so there is a difference here. Okay, it is a magnetically coupled circuit. The coils kept in the close proximity will generate the voltage in the nearby coil. That voltage we call it as mutual voltage. So kindly refer to the previous videos to understand what is mutual voltage. Okay, so first of all I am going to apply KVL at coil 1. So let us apply KVL at coil 1. So I1 is entering negative and leaving positive, so it has to be minus 24 angle 0. Angle 0 can be ignored because 24 angle 0 and 24 are same, plus self-induced voltage is J4 multiplied by the current flowing into it. So what is the current flowing? I1 is the current flowing into it. I1 is the current flowing in the loop 1. So J4 times I1. J4 times I1. Okay, and then there will be a mutually induced voltage due to the current I2. Here the I2 is flowing through the J4. This is my I2. I2 is flowing through J4. It is entering the undotted terminal. So the current entering through this J4 will be generating a mutual voltage across this J4. Okay, here the current I2 is entering undotted terminal. So the generated voltage positive will be at undotted, negative will be at dotted. So to understand this concept, go through the dot convention video. Okay, in the dot convention there is a rule for writing this polarity for the mutually induced voltage. Okay, so the current flowing through the coil 2 is generating a voltage across coil 1. Is generating the voltage across coil 1. Okay, if it is entering the undotted terminal, the generator voltage positive will be at the undotted and negative will be at the dotted. And what is the voltage generated? We have mutual inductance multiplied by the current. Okay, because the current is based on I2. So due to the I2 flowing through J4, I got a voltage across this. Okay, let us take this L1. Okay, this is L2. So due to current I2 flowing through L2, there is a voltage generated across L1, and this polarity is mentioned based on the dot convention. Okay, so now compare the polarity with the current direction. Here the current I1 is entering negative and leaving positive. Okay, so it means it does not obey the passive sign convention. So I need to write minus JI2. Okay, that is a mutually induced voltage, minus JI2. So this is self-induced voltage and this is mutually induced voltage equal to 0. Only these two elements are there, but I have written three voltages. One voltage is due to this voltage source and two voltages are due to the voltage across this inductor. Okay, two voltages are due to the voltage across this inductor. So if I have this inductor and there is another inductor placed in the close proximity and current flowing through both the inductors, there are two possible voltages you are going to get. One is self-induced voltage. For that the polarity can be written based on the current direction. And another one is mutually induced voltage. I'll just change the color for mutually induced voltage. I'll take blue. Okay, for mutually induced voltage, the current I2 is entering the undotted terminal. So generator voltage positive will be at undotted, negative will be at the dotted. The blue positive negatives for the mutually induced voltage, and then the current is I2. Okay, so will be, and the mutual inductance is J. So J I2. And what is the voltage here due to the self-induced voltage? The current I1 is flowing in this direction. Okay, I will change the color there. For I1, let us take red color itself. Okay, so this is I1. I1 is entering. Okay, I1 is flowing through this inductor. Okay, in this direction. So the polarity is assumed based on the current directions. Okay, so that it can obey the passive sign convention. So I am not changing anything. So it has to be positive. It will be J4 times I1. Okay, this is the value I will get. So J4 times I1 is the self-induced voltage, and then Ji2 is the mutual induced voltage due to the current I2 flowing through L2. Current I2 flowing through L2. Okay, and then polarity is based on the dot convention. Okay, dot convention is a rule. Okay, I2 is entering the undotted, so there will be voltage generated in the nearby coil. So positive will be at the undotted. Okay, if it is entering at undotted, the positive will be at undotted, negative will be here. So while comparing the current direction here, the current is entering negative and leaving positive. So it does not obey the passive sign convention. So it will be minus Ji2 equal to 0. So I am rearranging it to write the equation number 1. Okay, and then apply KVL at coil 2. Okay, apply KVL at coil 2. It is all the ends. So let us take, this is L1 and this is L2. For the namesake I am taking. Okay, next I will be applying KVL. So here first I will consider the self-induced voltage. In the red color I am writing the polarity of self-induced voltage, that is based on the current direction. And what is the voltage? The inductance multiplied by the current. Okay, the same current which is entering through the inductor. So J4I2. So it will be plus. So J4I2 will be plus. And there will be another voltage generated across this inductor due to the current I1. So I will take blue color for mutually induced voltage. So the current I1 is entering the dot. It is in clockwise direction. So it will be entering in this way. Okay, due to that there will be voltage induced across the L2. Okay, if it is entering the dot, so positive polarity will be at the dot and negative will be at the undotted terminal. Okay, this is based on what? Dot convention. The video is you have to watch the previous video. Just search for dot convention space Amardhan. You will be getting this video. My channel name you have to type and type dot convention. You can find that video. Okay, there I explain what is dot convention. Okay, so here I1 is entering the dot and leaving undotted. If it is entering the dot here, it will be generating the positive potential at the dot and negative at the undotted terminal. And what is the value which I am going to get? This mutual inductance J multiplied by current I1, because this voltage is generated across this L2 based on the current I1 flowing through the L1. That is why I am calling it as mutually induced voltage. Now check the current direction. The current direction is entering negative and leaving positive. So it does not obey the passive sign convention. So I will be writing minus J times I1 equal to 0. So I can rearrange like this. Okay. So I got two equations, 1 and 2. Okay, here I am always saying passive sign convention. If you don't understand what is passive sign convention, remember one thing. Okay, plus minus current I. If current I enters positive, leaves negative, it means obeys passive sign convention. If it enters negative, leaves positive, does not obey passive sign convention. What if obeys passive sign convention means V equal to IR, P equal to VA. This is the formula. If it does not obey, V equal to minus IR, you have to consider. Okay, P equal to minus VA. Okay, these are all things you have to remember. Okay, that is why the negative sign is written if it is not obeying. So if I apply Ohm's law, I am using a negative sign. Okay, if it does not obey the passive sign convention. Okay, now continue here. I got two equations. The second equation you can look at. You can simply take this minus ji1 equal to 0. Hereafter it is simple mathematics. So I am taking it to the right hand side. Okay, I1 can be written as J3I2 by J. So it can be written as I1 equal to 3I2. Substitute I1 equal to 3I2 in equation number 1. So I1 equal to 3I2 in equation number 1. Okay, if I solve it, I am going to get I2 equal to 24 by J11. So I2 can be written as minus 2.1818 J ampere. Okay, minus 2.1818 J ampere. Okay, and if I know what is I2, you can find I1 also. You can simply substitute that value here to find I1. Here the question is V0. So what is V0? So V0 is equal to what? I2 times minus J. Okay, I2 multiplied by minus J. Okay, so minus J I2 I can write. I can just substitute the I2 value here and find out what is V0. So V0 will be minus 2.1818 volt. In time domain, I can write minus 2.1818 cos 2t because angle is 0 here. I didn't get any angle. Okay, angle is 0 here. Okay, so I'll be writing it as 2.1818. It is written in this form, Vm cos omega t plus phi. Okay, so here the phi value is 0, so I can write in the place of Vm what we have 2.1818. Okay, cos omega we already know. Okay, which is in the first slide. Okay, 2t plus 0. This can be written as 2.1818 cos 2t volt. Okay, thank you. If you have any doubts, please post it as a comment.